Hello, Crystal community. Welcome to a quick little overview of libsunvox. Might not actually be a little bit quick, but it should be at least a good, fairly reasonable overview of Sunvox and how you can use it in Crystal to make music and whatnot. So here I've got open right now the example file. So all I'm gonna do is I'm just gonna, you know, all you really need to do is open it up and delete all the information here and just change the slot to 0. Doesn't really matter what slot it is, but I just prefer to keep it on 0. And then next you're going to go down to your terminal and you're going to install libsunvox. I don't have it installed, so when I actually run the example using /run example sh, it will complain and it'll say that it can't find the development package. But if you use sudo install sh, it'll be able to run the example. And there we go. And then you can test. Hold on, let me make sure it's working. Uh-oh. Testing, testing, testing. Hold on, let me find out if it's not working here. Testing, testing, testing. Nope. Oh, shoot. Duh. It won't do anything because I deleted the file. Hold on. Let me just undo that real quick here. We'll run the example again. Testing, 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 testing. There we go. Now you can hear. All right, there we go. So we've tested libsunvox and it works. If it doesn't work for you, I'd recommend opening a pull request with libsunvox because I'm still kind of learning what needs to get done to support some more architectures because it's got the Sunvox shared object does support a lot of different architectures. So something to think about for the future. But so yeah, all we're gonna do is we're just gonna, now that we've got it all tested, we're just going to delete all the stuff, change the slot to 0, and then we're going to start to work on figuring out a couple things about libsunvox. So first of all, let's actually just talk about Sunvox itself. I think that's a really important place to start. You can download it from warmplace.ru, and hold on, and you'll get it in a package like this. It'll have every architecture or whatever that the actual thing supports. So you find yours and you open it up. All right, and I'm just gonna create a new empty project. Okay, cool. So let's actually talk about Sunvox and kind of what it provides, in terms of music creation. So first of all, I think the most important thing to pay attention to if you just kind of move these windows around is this bottom panel, okay? It should just have a module called output on it, and then nothing on the left side, okay? And then you've got your piano roll. So the way Sunvox works is it's like a modular synthesizer. So essentially, you build sound off of modules that modify sound, essentially, right? So let me give you an example of what that looks like. So when we open up hold on, make sure my audio captures up here. So when we open up a new module thing, it lists every single module that's in Sunvox. These are all the modules that are supported as well by the shared object. So you can use any one of these inside your project and be able to alter it or play with it or even create new versions of those modules in the Crystal library. So let's start off with a generator because that's really one of the more simple ones to work with. It's really straightforward on how it works. Basically, when you click on the new module thing, you'll see that they're broken up into 3 categories: synth, effects, and miscellaneous. Okay, synths take notes and then output sound, right? So you put notes into them and then they play that note, through the instrument, right? Effects take sound and then modify that sound. So it's like an echo, for example, or an equalizer. All of those change the sound by you know being in the chain. So let me give you an example of what this looks like. So if I connect my generator and I press the Q key, it plays the note C4. So doing that allows you to hear the basic note, and as long as you're selected on the module you've created, your Q, W, E, R, and etc. keys, all of those play notes from the piano roll. So you can play around with the thing or whatever, right? So let's break down some terminology here to kind of explain some important stuff. So you've got these guys, which are modules, right? And every module has controllers on it. This is what a controller is. It has, like, for example, volume, right? Volume is its own control. You've got waveform, which allows you to change which waveform comes out. So we did have a triangle, but if we change it to a saw, it's going to sound different as a square, or the noise, or this weird drawn thing where you can draw the output or whatever. There's a bunch of different waveforms, and they all sound different and allow you to start with different sounds. Basically, a module won't play if it's not connected to output. So that's something to always think about, is that all your modules, if you want to hear them in some way, usually need to lead to output in some way. So if I take this out and I press the Q key, it's playing the note, as you can see up here, but it's not making any noise. But then once we put it in, there you go. Yeah, we'll hear it. Okay, cool. So this is connecting modules, essentially. Now let's add another thing into the mix here. So we're going to add reverb, right? So reverb kind of like creates this feedbacky echo. It sounds like you're kind of like in a big hall or something. So that changes the sound, essentially. So that's what an effect is, right? Now, what's really cool is that the controllers can control things about how notes are played or how the sound comes out. So for example, on this generator, right, we have two important controls: attack and release, right? So attack is how quickly the sound starts up, and then release is how quickly the sound lets go after the note is done playing. So if we press C3, right, the second I press, the thing starts, but then the second I release, it's done, right? If I bump up the attack really, really high, watch what happens. So you get this like slow come up. And release will do the, opposite. When you press it, once you're done releasing it, it continues going. So you can combine these to make some kind of nice sounding instruments. So that's kind of like the basics of, most of what you're going to need to know in SunVox in terms of, just playing around with sound, essentially. But there is an extra aspect to it, and that is the tracker / timeline pattern kind of system. So essentially, when you want to have SunVox play a song for you, it will do it perfectly on beat. You just have to tell it when to play the notes. So for example, if I come in here, let me change the step to... All right, and then we'll press the play button. And then it'll play those notes for you at the speed you define, which you can define in these project properties. You can tell how many beats per minute and how many ticks the engine should take to make a single line. So that is just a simple way you can control stuff, and all of this stuff is readable in Crystal, so you can get a pattern's uh, like note data essentially, and track data. One aspect of this is that the timeline here allows you to arrange the patterns. So if I create a blank one, you can arrange them how you want. So, if you want like drums to come in halfway, you can arrange it right here. There's all sorts of different ways for you to position your patterns, and you can go through those patterns in Crystal as well. So each pattern has its own collection of notes, but you can also do things like duplicate them, oh, or clone. There we go. Oh, clone, come on. There we go. Yeah, so you can get these cloned versions of them. Um, but in Crystal, that just still looks like it's its own pattern. That's just internally for SunVox. But yeah, that basically sums it up for SunVox. Like, realistically, this is most of what you need right here. Is just connecting modules, taking some of the modules and connecting them up. We'll just go over a couple really simple modules to talk about. One of them is input. Where is that sucker? Here we go. So input actually takes your mic. So you can see as I'm talking, it's actually uh, getting the mic data. But we're not gonna play that because that's gonna be annoying to hear my voice multiple times. Um, there's drum synth. So drum synth works in a really interesting way. Each of the drums are like configurable. So you can configure like your bass drum and your hi-hats and your snares and whatnot. But what it does do is it since drums don't necessarily respect a note. I mean, they are like technically a note, but like you wouldn't want a drum roll, like a piano roll that could play at like every single like tom note essentially, or like drum note. That's not really how like drumming works. So instead, the each of them are broken up into three groups. There's four notes that are a bass drum, three notes that are a hi-hat, and then five notes that are a snare drum, and then it moves up an octave. So you get bass, 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 hi-hat, 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 and then snare, 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 right? And then it restarts. And you get, I think, like a variety of different ones, because like this 9 one is like super punchy. But yeah, either way, so you get you essentially between these guys you have a drum synth and the generator. So those are basically most of what you're going to need. And this Mystic area, that's more for when you get into really starting to understand some of the cool stuff that SunVox can do. But for now, let's actually jump into doing some Crystal programming because we've talked enough about this part. So when you start the SunVox engine, right, you don't actually need this end bit, okay? It will probably just automatically configure and work for you. But for me, my mic doesn't work, but my audio does normally. But when my audio is connected to my computer, like it is now, so you can listen and hear what I'm hearing, or what we're supposed to hear out of the system, that's when it gets a little different. In fact, let me see if I can actually set up monitoring here. Properties. Can I monitor this? No, it doesn't let me. I guess OBS won't let me monitor my own thing. Oh well, that doesn't matter. So let's just jump into some stuff that we can do here. So first of all, right, we're gonna want to actually create some modules. So let's actually create a generator module to start out with. So how that works is you say generator, right, equals SunVox dot new module, and you're going to put the slot that the generator is going to go in. What that means is that SunVox has 15 song slots that you can put a song into, which would essentially be a single project in SunVox. So, you know, in this instance, we're really going to use one, but there may be cases where you want to play multiple songs at the same time, and to do that, you can use multiple slots, and you know that way you're not, you know, doing anything that SunVox would be unhappy with. It'll just manage that for you. But so we're gonna make a new module. We're gonna pop in a slot, and then all our modules are located in SunVox modules. Um, and we've got synths and then generator. So what this is gonna do is this is gonna pop out a number. That number is gonna be our module number, which is if we actually go back into SunVox, you'll see here that there is a 3 or a 1 or a 2 or a 0. That's the module number of the you know, module. So if we were to, for example, save this SunVox file and then load it in to Crystal, we could access the drum synth, for example, by referencing its module number 03. But now that we've created our generator, let's just wire it directly to output. So what we're going to do is we're going to say sunvox.connect module, and we're going to give the slot. We're going to say which where the source is, and then where the destination is going to be, which is going to be SunVox output module. Oops. Okay, cool. So now our generator is hooked up into you know, hooked up to the output, so it will play noise. So let's learn how to quickly send an event to the module, right? So SunVox has a very simple event system to send an event, and you can just do it by send event, sunvox.send event. You say the slot you want, the track number you want. Now this is important, right? It's important in some instances, but it's important enough. You'll notice in this pattern there's there's 4 tracks. Okay, there's track, let's say 0, 1, 2, and 3, right? So if I actually go in and I pick a pattern, right? You can change the number of tracks to be fairly large, right? What each track allows is it allows a note to be played at the same time as another note. So for example, you know, this 01, I could add, you know, oops, let me go back here and select my generator. I can add you know, a chord essentially here, and when SunVox plays this file, it'll read and play all 3 of these notes at the same time, creating a kind of chord, right? But that only works because they're on separate tracks. So you can't play 3 notes on track 0 using an event. It will overwrite the event previous to it, essentially. So we'll kind of go over this. I'll show you an example, but we're gonna choose track 0 for now. And then let me just pull up something real quick here. There we go. All right, cool. So once you get the track number, then you can do the note next. So you do that by using SunVox note. And then I have all of them labeled, and they allow you to also use math on them to move them like up and down the different tones. So let's just pump out a C3 into it. Then the next item that we need to pay attention to is velocity. So velocity is how hard the note should be hit. At 0, it hits the note as hard as it can, but at 1, it hits it incredibly lightly. You know, and then when you go up to 100, I think it's like 127, that's where it starts to get, you know, its hardest again. I don't know why it's like that, why it starts at 0 and then goes to 1 like that, but that's just the way it is. So we're gonna send this event, right? And Now, what's going to happen, right, when we actually start this? Let's run the example here real quick, and I'll show this off here. All right. Is it working? Uh-oh. Hold on. I must have messed up somewhere. No. Oh, duh. I forgot to put the module that it needs to go out. That makes sense. Yeah, an event can actually have no module that it specifies. So you'll hear that this tone keeps on happening, right? And the reason why it's going on is because we never sent a note off to the system, so it's going to keep playing that same tone forever, right? So let's fix this here. Let's go and so we want the sound to play for a period of time, so we'll let Crystal time it for right now. So let's sleep 1 second, okay? And then we'll go sunvox.send event, and we'll make sure it's on slot 0, and sunvox note off. So now when we restart the program, we'll hear a tone for a second, and then it'll turn off. All right, so easy enough. Okay, so let's start getting a little bit more involved here and get through some stuff. So the generator module has 10 little controllers essentially that we can use. Okay, there's a waveform one that lets us change the waveform. There's attack and release. Those are the big ones we care about essentially, right? Now, when you look at attack, it has a little number next to it, 04, and release 05, okay? Those are the controller numbers, so when we want to change them in Crystal, we're going to need to remember those, right? Now, the other half of it is that the way the system works is it chooses each controller can have a value between 0 and like it's not 8,000. It's way higher than that. It's like 32,000 or something like that. But oh, I'm sorry. It's that's the hexadecimal version. It's so you can have up to like hexadecimal 8,000 or something like that. Like a really high number for the controller value. But all the controllers can't act differently. So a big thing to look at is that this little number in the parentheses is the number you will set it to in Crystal if you want that specific effect. So an example would be like, if we want the attack to be 512 in Crystal, we'll set controller 4 to the value of 0x8000, and then that will set it to 512. So we'll kind of show some of that here real quick. So let's start by setting the attack and the release of this guy and get it all set up. So we want to do it before we send our notes, obviously, or else it won't play the right sound. So let's go in and we'll say sunvox dot let me pop open my docs and make sure I get this right. Oh yeah, that's right. So, okay, so it's going to be send event. So all controller changes can be sent as events. So there's no direct way to control a controller. But the send event essentially is as direct as it gets. So we're going to say slot. We'll say track 0. We want the note off again because we don't want any note to play. And we're going to target generator, right? Now we're going to start getting into the part where we start to change our controllers, right? So we do CTL, and we're going to pick 04. right, which is our attack. And then we're going to say CTL value, and we're going to set that to 0x1000 for now. So 1/8 of the attack value, right? Now we're going to do the same for release. So we're going to pick a release, okay? So now when we actually hit this, what'll happen is it'll go for 0.1 seconds and then shut off, and then we'll hear the attack in the actually I'll just set it to 1. So we'll hear the attack in the release essentially. So simple enough. It's a fairly simple system to send, the information you need to get the controller set up. So yeah, as we build, upon stuff, most of what we're going to be using really is send event to set controller values or whatever. So let's add a new module here, right? Let's add reverb. Oops. So I'll do SunVox new module, and then we'll say SunVox modules effects, and then reverb. Oops. Great. And then so instead we're going to connect reverb to out, and then generator to reverb. Okay. And now when we start it up, we should hear the reverb sound. And there you go. So yeah, that's pretty much, most of what you're gonna want to know to start out, because you can get most things done just using this and timing with Crystal. For a little bit of an advanced kind of look at some of the stuff you can do later. So you'll notice that like we have to use sleep, for example, in Crystal to time our events, and that's not good, because even though Crystal's fast, if there's any chance that the sleep doesn't end at exactly 1 second for whatever reason, because from my understanding, Crystal, can choose any fiber to run at any time potentially. So, just because you said sleep for a second doesn't mean it will come back in exactly a second. So we may actually need to time ourselves a little better. So we can do that using something called set event time. So we're gonna take a quick look at that real quick. So first of all, we're going to keep the stuff that we got already, except we're just going to delete the actual notes that we sent out, right? Now, what we're going to do is, oh yeah, that's right. Also, instead of sending off, that was my bad. Instead of sending offs, you should send nuns for controller values, because none doesn't do anything, but if you send an off note and then can change a controller value at the same time, it'll turn off the generator, but then also still change the controller values, which is probably not what you want. So we're going to leave that as it is. So let's go get some important information. So there's 2 key pieces of info we need. We need SunVox ticks per second. And then we're going to need ticks. Okay. So, So let's explain both of these. So ticks per second is how many times, I guess, SunVox updates per second. Okay. I think this number is around 50,000, right? Then ticks is a kind of like clock value that tells us how many update calls has been done between between or in a frame of time essentially. So like if we call ticks twice, right, we'll know how many ticks has happened in between our 2 ticks calls, right? So it's like a super useful tool just to time ourselves against SunVox. So let's take a look at how this works, right? So when you use the sleeps, right? You know, obviously you're sleeping crystal. You might not want to do that. What this allows us to do is send all our notes at once, and then SunVox will just kind of like figure out which ones need to go where in the future. So let's actually show what that looks like. Okay, so I'm gonna create a scale, and the um, SunVox, or at least my SunVox library, has some utilities for making scales. So I made a scale here that just is off the note C3 and uses the hexatonic scale. Okay, so what I'm going to do is I'm going to say scale.each. Okay, and that's going to produce a note. Oops, do. All right, so that's going to produce a note. And what we're going to do is we're going to say SunVox dot set event time, okay, and we're going to say ticks, and we're going to say plus equals, oops, actually we're going to need to use the slot first, and we're going to say ticks plus equals, and we want to do a quarter of a second, so we're going to do a quarter of the ticks per second added to ticks, and we're just going to make sure that's an integer. Okay, because ticks is an integer. Okay, so what just happened here, right? So what I'm doing is I'm setting ticks. I'm setting ticks, but I'm adding 0.25 of a tick per second. Okay, or of all the ticks per second. So basically, what this does is it just gives us a number of ticks per second. We can divide that and then just add that to ticks, and that tells us our future time we'd like to play our note, right? So what this does is this actually sets SunVox to now all notes, future send events will happen at this time. Okay, so we're going to say SunVox dot send event. We'll say slot, track 0. We'll give it the note. We'll give it the velocity, and then we'll tell it to do generator. And there you go. Okay, cool. All right. Now, yeah. Okay, cool. So, now what that, actually there is one other thing I need to do. Oops. I need to, okay, so each time we run this ticks plus equals, we're going to advance time by a quarter of a second. So what I want to do is I want to play the note, play it for a half second, and then note off. So that way it will stop playing the note and then get ready to play the next note. Oops. All right. Cool. So this will do all of that, right? Then all we need to do is just sleep and then wait for the ticks to catch up, and then we're all set. So if we go in, hopefully this works. It's a little hard for me to hear in SunVox. So yeah, you should be hearing the tones going up, and then it should be happening sequentially, right? And that's because of set event time allowing us to set the event time in the future. So yeah, overall, the libsunvox library is a lot of fun. I really hope some people in the Crystal community can find some cool use in it, because not only is it fast enough to run for like games, but you can create a lot of the sound effects that you might need for like games or like music applications or really just anything. And yeah, I just hope people will find some use for it. Well, thanks for watching. If you want to check out the project, it's on my GitHub page. Let me just pull it up here. There you go. It's on my GitHub page, github.com/sol-vin/libsunvox. I also have docs as well, which includes basics, which is everything that we pretty much talked about today, and examples, which are just kind of, a little bit, more hands-on with what you can do with SunVox. Well, thanks for watching.